Hello guys, welcome to Ramta Solutions and welcome to your vertical projectile motion lesson. Today we are looking at your past papers, and before we proceed, if you are using a cell phone, please rotate your screen so you can have maximum viewing of this video. Okay, if you do that, you will be able to see the writing better. Right. Perfect. So, this is a question from my beloved province, Bokoni-Bupirima, the Northwest Province. The paper was written in September 2022. So, it reads as follows. A helicopter moves vertically upwards at a constant velocity and then releases a package. It takes 6 seconds for the package to reach the ground. So delta T is 6 seconds, what? To reach ground. Right? To reach ground from moment of release, right? The package strikes the ground with a velocity of final velocity with a velocity of 49.8 meters per second. I'm going to say downwards because they say this object was projected vertically upwards. Okay, so obviously to strike the ground will be a downwards motion. So 49.8 meters per second downwards. I think I should also mention to strike the ground. Alright, this is for the object to strike the ground or the package. Now, ignore effects of air friction. Question 1 says, define the term free fall. What is free fall? So free fall is motion in which the only force acting is the gravitational force. Alright? Can say when I say motion of an object, it doesn't matter. Motion in which the only force acting is the gravitational force. Alright? Is the gravitational force. Right? The only force acting is the gravitational force. Question 2. Why does the package rise before falling to the ground? So, the reason the package falls before falling to the ground, this is one video that we uploaded on relative velocity. So the reason is simply the package has the same velocity as that of the helicopter. Okay, this is why it's rising. So we will say, let me write it down. The reason is that the package has the same initial velocity. Has the initial velocity, let me say, has the initial velocity, which is similar, which is similar to that, which is similar to that of the helicopter. Okay, which is similar to that of the helicopter. Yes, which is similar to that of the helicopter. This is why the package is rising before falling to the ground, okay? It's basically moving at the same velocity as the helicopter, okay? Okay, perfect. So, if the time taken for the object to reach maximum height, let me go to the next page. Question 3 says, if the time taken to reach maximum height is 0.8 seconds, calculate the velocity of the package. So here we are looking at the initial velocity because we know at maximum height, velocity is 0. So these are vector calculations. First, I will say I'll choose upwards being positive. So I will take VF equals VI plus A delta T. What is VF? At maximum height, velocity is 0. We don't know what the initial velocity is. What is the acceleration? Because it's it's 9.8 meters per second downwards, and we chose upwards as positive, it'll be negative. So it's negative 9.8. What is the time? The time is 0.8. Right? So what is this? So this is, let's see. 9.8 times 0.8. 9.8 times 0.8 is negative 7.84. So VI minus 7.84, implying initial velocity is positive 7.84 meters per second. They said velocity, meters per second upwards, as you can see. Alright? Even the calculation was proving that indeed it was 7.8 meters per second upwards, or rather 7.84 meters per second upwards. Right? As you can see, we are getting a positive value here. Okay? Perfect. Number four, it says draw a velocity time graph that represents the motion of the package until it reaches the ground. Indicate the initial velocity, final velocity, and times for the entire motion. Oh, I like this question. I like it. Okay, so let's not waste any time. And let's see what we do. So we are going to say, okay, because this is what they want us to do, let's see. Number 4. Oh, I didn't read the right question. Number 4. Calculate the height of the package above the ground at the moment it is released from the helicopter. So this is easy. We know the initial velocity. We can find the height, right? We can find the height, and we also know the time of the duration of the package to strike the ground. So we will say this is, we're still going to continue and say again, upwards is positive. This is the direction I want to take as positive. Now I will use delta y equals vi delta t plus half a delta t squared. So let's read the question again. Calculate the height of the package above the ground at the moment it is released from the helicopter. This will give us the height of this object at the moment it was released. Okay, let's see. What was the initial velocity? It was 7.84. What was the time? Time to strike the ground from the moment of release is 6 seconds. Acceleration is negative 9.8 because we chose positive to be upwards in order to be positive. Alright, let's get our answers. 7.84 times 6 minus 4.9 into 36. What do we get? We get negative 129.36. Alright? We are getting negative 129.36. As you can see, this is a negative value, implying that from the moment that the object was released, it was 129.36 meters above. Therefore, let's conclude this. Therefore, let's conclude this. The package was released at a point, okay, I'm going to say this, it was released at a point 129.36 meters above ground. Okay, it was released at a point that was 129.36 meters above ground. Okay, that was the height. Okay, that was the height of the package. Okay, so if you left your answer like this, you will have to conclude your answer. Even if you can leave it, say, instead of writing this whole statement, you can say it's 129.36 meters. It's okay, that is the height. Okay, or you can say, instead of this, you can say, therefore, you can say instead of writing this one, you can say therefore height is 129.36 meters. That is still okay. All right. Now, number 5, the one I was rushing for. It says, draw a velocity time graph that represents the motion of the package until it reaches the ground. Indicate the initial velocity, final velocity, and times for the entire motion on the graph. This is acceleration versus time. I've been velocity versus time. I've been taking upwards to be positive, so I'm gonna continue with it and say, okay, if that's the case, I'm taking this one here, I'm taking this one here. So what is our initial velocity? I believe it was, let me go back, it was 7.84. So it'll be 7.84. This is velocity in meters per second, in meters per second, and then this is time in seconds. It takes 0.8 seconds to reach maximum height, and then it takes let me use a line here, and then it takes how many? It takes 0.6 seconds to reach the ground, right? So this will be 6 seconds to reach the ground. And what is the velocity that the object struck the ground with? It was negative 49.8, right? This 49.8 meters is the velocity that the package struck the ground with. Okay. All right. So as you can see, we have shown the times. From the point of release time 0, initial velocity was 184. It reached maximum height after 0.8 seconds. Why did I say 104? 78.4. You see, it's also confusing me. Let me write this a bit bigger. 7.84. So yes, initial velocity was 7.84 meters per second. It reached maximum height after 0.8 seconds. Then it struck the ground after 6 seconds from moment of release. It struck the ground with a velocity of 49.8 meters per second downwards. Okay, so this is your velocity versus time. I think I need to add some information on this if you are struggling with this. Remember guys, velocity versus time is basically coming from velocity equals, final velocity equals initial plus a delta t. If you choose upwards to be positive, your a will be positive, right? Your a will be positive 9.8. So you have Vf equals Vi plus 9.8 delta t. You are plotting velocity versus time. As you can see, this will be your constant, this will be your gradient, right? So this therefore tells you with this gradient, when it's positive, your function is like this. But if you choose acceleration as negative 9.8, you have V sub f equals Vi minus 9.8 delta t. Then your gradient, as you can see, is negative. Your function will look like this, or your graph will look like this, negative slope. Hence, the graph looks like this because we chose upwards as positive on a low. So this means you can also draw this function in this way. You can also draw this function in this way. If you choose downwards as positive, you can also draw it in this way. It'll be negative 7.84. Okay, it'll be negative 7.84, 0.8 here, and then 6 seconds here. And then what is this? This is velocity in meters per second. This point here, which was your final velocity, it was 49.8, right? It was 49.8. So your graph can also be like this. Okay, that's if you chose downwards as positive. Your graph can be like this. Okay. So use your graph in question 5 to determine the maximum height the object or the maximum height reached by the package above its point of release. So I'm using this graph here. because they said we must use it, they didn't say to us we must use equations of motion. So we're going to find the area under the curve, because the area under the curve gives us the height. All right, let's see. It'll be number 6. It'll be area or height, sorry. Maximum height reached. Maximum height reached is equal to area under curve, right? Which is half times base times perpendicular height. But for which times? For 0 to 0.8 seconds. Right? Let's go. Half times, what is the base? I think it's 0.8. Let's go and confirm. Yes, the base is 0.8. So I prefer to use this one. The base is 0.8. And what is the height? It's 7.84. Can you see that? The height of this triangle is 7.84. So it's 7.84 times 7.84. So the reason I wrote 0 to 8.5 seconds is because I want to tell you that you must focus on getting the area of the piece within 0 seconds and 0.8 seconds. Okay, perfect. So let's see, what is our answer? 0.4 times 7.84. What do we get? We get 3.136, which is like 3.14 meters. So maximum height reached above point of release is 3.14 meters. Right? It is 3.14 meters. Right. Perfect. Now, the 7th question says, after releasing the package, the helicopter continues to move vertically upwards with the same constant velocity. Calculate how much higher the helicopter moves from the time it releases the package until the time that the package reaches the ground. So here, let me go to the next page. For this question, we have the velocity, right? Do we? Yes, we have the velocity, right? We have the velocity, which is, remember, at question 2, we asked, why does the package rise before falling to the ground? Our answer was that this is because the package will be moving with the same velocity as the helicopter. And what is that? We got that value to be 7.84, the constant 7.84. Now, how much higher? Because you're going higher, you don't say delta x, so we're looking for delta y. Now, what is the time? The time taken for this motion was 6 seconds, and we know our definition of velocity is delta y over delta t. Now, what is this velocity? It's 7.84. What is the delta y? It's unknown. What is the time? It's 6 seconds. So let's calculate it. Or rather, let me say it'll be delta y equals 7.84 multiplied by 6. So let's see, 7.84 multiplied by 6. Our answer is simply delta y is 47.04 meters. Can you guys see that? The helicopter has moved 47.04 meters after the package was released. Okay, so this is how you attempt these questions, and I want to believe that this question will help you with your studies. So with that being said, it's a wrap, and bye-bye.